fellow on maths, fellows in the building. So now we are going to talk about the third factor that can affect our chemical equilibrium. So we're going to talk about temperature. So how does temperature affect our chemical equilibrium? So we say if the temperature is increased, the endothermic reaction will be favored. Why is the endothermic reaction is favored? Because the endothermic reaction is the reaction that can decrease the temperature in the system. So according to the Chatelayer, everything that we are going to do, every factor that we're talking about, we are talking about the reaction. We favor the reaction that will oppose the disturbance that is made. So here the temperature was increased. We favor the endothermic reaction. So this is not how you answer, but this is to understand. What I wrote there is to understand why is the endothermic reaction is favored. So pre-knowledge from grade 11, you know that the endothermic reaction absorbs energy. So if the temperature was increased for that system, the endothermic reaction will use that energy. Will favor the endothermic reaction. Why? Because we use the energy produced. So the energy, it is in form of heat. Temperature is increased, we're talking about heat. So the energy produced is in terms of heat. So consequently, when we use the energy produced, the temperature will decrease. So we absorbed that heat. So the temperature will decrease. So now we're going to talk about when temperature is decreased. So if temperature is decreased, the exothermic reaction will be favored. Why? Again, pre-knowledge from grade 11, you know that the exothermic reaction is the reaction that releases energy. So now we are talking about the exothermic reaction. The energy is released in terms of heat. So the energy is decreased in the system. So the system will say, okay, let's favor the reaction that will produce heat. So in other words, the reaction that will release energy. So releasing energy is producing heat. So when you produce heat, consequently, the temperature will increase. So we decrease the temperature, the system on itself, it increases the temperature. That's Le Chatelier's principle. The system in a closed system will always favor the reaction that opposes the change. So the words in red, they say, note that the heat of reaction is always used to indicate the forward reaction. So you're gonna see in the questions that you have of temperature, you're gonna see the heat of reaction, the enthalpy. You're gonna see it. So it is used to indicate the forward reaction. So meaning the reverse reaction is the opposite. So they say again, note that an increase in the rate of both forward and reverse reaction. No, an increase in temperature actually. An increase in temperature increase the rate of both the forward and reverse reaction, but it also shift the equilibrium shift. So when you increase the temperature and when you decrease the temperature, both the forward and reverse reactions, their rate will decrease, but the equilibrium will shift. So when you talk about the equilibrium shift, we're going to talk about favoring the reverse or the forward reaction. So the temperature change is the only change that can affect Kc. So what is Kc? Kc is the equilibrium constant. So we're going to talk about Kc again. So this is question number 1. They say for this reaction A plus B, they give us AB. So the rate of reaction is the heat of reaction is negative. So which means the forward reaction is exothermic when the heat of reaction is negative. So they say temperature is increased. Using Le Chatelier's principle, explain what will happen to the concentration of AB. So this is how you explain it. You tell them firstly the disturbance. So the temperature was increased. So according to Le Chatelier's principle, when the temperature is increased, the endothermic reaction will be favored. So our reverse reaction will be favored because the forward reaction was the exothermic. So the endothermic reaction is the reverse reaction. So you see how it goes. So consequently, what will happen, because the reverse reaction is favored, the reactants will increase. So A and B will increase, then AB will decrease. So for this question, they say for this reaction A, B, it forms our A and B. So the heat of reaction is negative, which means our forward reaction is an exothermic reaction. Then they say the temperature is decreased. Explain in terms of Le Chatelier's principle what will happen to the concentration of A. So you're going to state the disturbance that the temperature was decreased. Then according to Le Chatelier's principle, when the temperature is decreased, an exothermic reaction will be favored in order to increase the temperature by releasing heat again. So the forward reaction will be favored. So AB, when the forward reaction is favored, it means the reactants are used to form the product. So the reactants will decrease, AB decrease, then the products will increase, A will increase, then B will increase. So we have answered the question that what will happen to the concentration of A. So A will increase. So for the last question, for this reaction, A plus B, they form AB. So again, they say the heat of reaction is equal to 47 mole per kilojoule. So it is positive, which means when it's positive, the forward reaction is endothermic because the heat of reaction is positive. So again, they say A is a blue chemical and AB is a colorless chemical. Explain in terms of Le Chatelier's principle what happened to the temperature if the color of the beaker changed from blue to colorless. So the blue chemical is our reactant. So the colorless chemical is our product, which is AB. So we moved from reactant to product, which means we favored the forward reaction. Now we have to identify that what happened to the temperature. Did we increase the temperature or did we decrease the temperature? So this is how you explain it. You tell them firstly that the endothermic reaction was favored. Why do we say the endothermic reaction was favored? Because we can see that the forward reaction was favored, and we talked about that the forward reaction is the endothermic reaction as given in the statement. Then from blue to colorless, we can see that that is a forward reaction. So we say the forward reaction is favored again. Then after saying the forward reaction is favored, you state the Le Chatelier's principle that according to Le Chatelier, the endothermic reaction is favored when the temperature is increased. So you have answered the question. So this one is a reverse question. It's a reverse question. You go back to you state the results before you tell them the change, the disturbance that was made. So it's a reverse question. This one, you need to tell the disturbance that was made. The disturbance is not given here, but you are given what the result. So this is how you answer it. So that's it for this video. Thank you, fellows on maths, for this in the building.